Hello. So we were modeling the traffic lights case study, and so far we have successfully modeled the structural aspects, behavioral aspects, the timer and the clock models. So now we will be heading towards the constraints modeling. So normally in UML or SysML, the constraints are written in the object constraint language, which is an OMG standard, object management group standard, used to specify the constraints. It is basically the query expression language in UML models. There are different specifications of OCL, but in this case study, we will be generating the system Verilog code, which is basically the hardware description language, which also provides enhanced hardware verification aspects. So for that purpose, we need to represents the SV system Verilog constraints. So for that, we have extended the OCL language and proposed SVOCL to represent the system Verilog concepts at higher abstraction level. Basically, the idea behind proposing SVOCL is that to represent the assertions and properties of design at higher abstraction level, but also significantly reduces the transformation efforts. So for to represent the SVOCL constraints, we will be using the Ocl editor already given in SysML, because we ultimately will lead to the transformation model to text transformation, in which we will be generating the system Verilog code. So the Ocl editor will also give us the constraints written in OCL, though it will not validate the model successfully. The Eclipse validator will not validate the model successfully, but while transformation, the code will be successfully generated for the constraints. So to represent the constraints, we will be using the Ocl editor, and to use the Ocl editor, the constraints can be written in any diagram, whether it is BDD, whether it is time activity, or whether it is behavior, state machine diagram. So you can write the constraints in any of these diagrams. So in this case study, we will be writing the constraints in the system state machine diagram. So for OCL editor, go to the nodes section of the palette here. This is the state machine diagram we have already discussed in previous videos. So for Ocl editor, go to the nodes section here in the palette. Here is the constraint. This is basically the Ocl editor. So just drag and drop it onto the editor. So you can delete the context link from here, because you can delete the context link from here. Okay, just delete the constraint box first. Again, drag and drop from the palette onto the diagram. It will then ask you for the context, that what will be the context for this constraint. So I'm not selecting any context for the time being, so press escape and it will not then ask you for the context. So you can here is the constraint box. Okay, so you can rename the constraint box in the UML tab of the properties section. Here you can name it whatever you want. I'm just naming it constraint 1. Okay, so now you have to, in the properties view, you have to set the context for this constraint. So for that, this is the context part of the constraint you are just about to write. Browse for the context. Okay, the window will be opened for the context. You can then browse in your SysML model you have created. Browse for the component or block or FSM which you want to set the context for this constraint. So I am setting FSM as a context for my constraint. Okay, so the FSM has been set as context for this constraint. Okay, now I have to write the constraint. So the first constraint I am writing will be that to ensure which will be for that to ensure that both lights means north south light and EW light will not be green at the same time. So this constraint will ensure that north south and east west road doesn't have the green light at the same time. Okay, to write the constraint, just double click on the Ocl box, constraint box, or alternatively you can press F2. Select the constraint box and press F2. Okay, now you can write the constraint you want to write. So I'm writing the first constraint I'm writing will be for that no green light at the same time. So for this I'm using this if this if then parenthesis and then not what I've defined here, reset. Okay, not reset. Now not reset and bracket closed. Then the if brackets, it will be square bracket. Okay, so the constraint is not, then parenthesis and then ns light is equal to g or green, not ns light is equal to green, and EW light is equal to green. Then close square bracket and then end this if. Okay, okay. This was the constraint which basically ensures that both the roads north south and east west do not have the green light at the same time. then you can click outside the constraint box and your constraint is written here. Okay, let's resize the state machine. Okay, here is the constraint one we have just written. Okay, basically the small cross at the top corner of the constraint box, basically it is because that the this if keyword is not in OCL. It is basically the OCL extension SVOCL, which contains this. So we are just using the OCL editor for SV system Verilog constraints, and we are not using a separate editor for that. That's why it is giving the error, because the constraint will not parse successfully. Okay, the first constraint have been written successfully, so we will be heading towards the second constraint. So for that, again go to the node section of the palette, search for the constraint box. Here it is. Just drag and drop it onto the editor. Okay, I'm not setting context from here. Press escape. Okay, now you can rename it whatever you want. I'm naming it as constraint 2. So go to properties section and UML tab, and then you can rename it as whatever you want. Okay, now you have to set the context for this constraint. So for that purpose, go to the UML properties tab, browse for the context here. Okay, now in SysML model, browse for the element you want to set as the context for this constraint. So I'm setting FSM as the context for this constraint. Okay, now the second constraint will be that the north-south light should be off at reset, or in other words, whenever there is a reset, the north-south lights status should be in off state. So for that, double click on the constraint box. So in SVOCL, there is a function called SV implication. The SV implication basically has two types, overlapping and non-overlapping. And basically it has two parameters. The SV implication function has two parameters. The left parameter is called antecedent, and the property on the right side is basically called as consequent. The implication will result in vicious success if antecedent fails. In other words, the expression on the left side inside the function, SV implication function, returns false. Then the implication results in vicious success. Now, if antecedent is successful, then consequent is evaluated separately. I will repeat this, that antecedent is the expression written on the left side inside the function, and the consequent is the property or expression written on the right side of the function, inside the parenthesis, of course. And implication is successful if consequent evaluates to true, and implication is unsuccessful if consequent evaluates to false. Now there are two types. I have already said there are two types of SV implication function. Number one is overlapping and number two is non-overlapping implication. In overlapping implication, consequent is evaluated on the same clock tick of successful antecedent. And in non-overlapping implication, consequent is evaluated on the next clock tick of successful antecedent. The result of implication can be true or false. It will return a boolean. Okay, now we will write the constraint, our second constraint, using SV implication function, which basically ensures that NSLight status should be off at reset. So for that we will write the constraint SV implication then parenthesis and then reset is equal to false, comma, NS light is equal to off, comma, 0. This is basically the constraint number 2 for our case study, which basically ensures that NS light will be off at reset. So we have now written two constraints for our case study. Now we will be writing the third constraint. For that, go again to the node section of the palette, drag and drop the constraint box onto the state machine. I'm not using any context from here, so press escape as I'm setting the context from the property section. Okay, sorry, yes. Now you can rename it as in the properties section UML. I'm renaming it as constraint number 3. Okay, now you have to set the context for this constraint. So go to the properties. Here is the context. Browse from this button for the context. Okay, now in SysML model, search for the context. I'm setting FSM as its context. Okay, and okay, now FSM has been set as context for this constraint. Okay, now I want to write the constraint number 3, which basically ensures that whenever there is a reset, EW light status should also be off. So double click on the editor will open. Now you can write the same constraint. Basically it is the same constraint, so we'll be using the same function called SV implication. So SV implication parenthesis reset is equal to false, comma, EW light is equal to off, comma, 0. Sorry, EW light. EW light. EW light, have we oh sorry, we have basically declared as NS state and EW state, so we have to correct this is not ns light, it's basically ns state. That state in north south FSM should be in off state, and we also have to correct it here as EW state and NS state. Okay, and also we have to correct it here EW state. Okay, now it is not giving the error here. Okay, so we have written the third constraint successfully, which basically ensures that the EW state should be in off state whenever there is reset. Okay, the rest of constraints we will be writing in the next video.